Bismillahirrahmanirrahim. Assalamu alaikum. Have a good day. Hope you are taking your classes on regular basis. And this is the third segment of our topic that I started two lectures ago. That was amines. In our previous lectures, we have discussed about a brief introduction, classification, and nomenclature of amines. That was discussed in lecture number 1. And in the second lecture, we talked about reactions of preparative methods of amines. And in that lecture, we studied that there are two methods for the preparation of amines. One of them was general type for the preparation of amines, and that method is used for the preparation of a variety of products. And the other class, that was a specific method, was used to prepare a specific molecule. In this lecture, we shall talk about reactions of amines. Here are some important types of reactions of amines. The first one is salt formation, because amines have basic nature, so they have tendency to form salt with any sort of acid. Second one, they are used to alkylation. This is something like the reactions that we have studied in our previous lecture. Means primary amines are used to prepare secondary amines, and secondary amines are used to prepare tertiary, and tertiary are used to prepare quaternary amines. And there is a subcategory of alkylation, that is Hofmann degradation. The third class of reactions that usually amines do, that is acylation. Acylation is addition of CH3CO group in any molecule. And the fourth type of reaction is carbylamine reaction. And the fifth type of reactions that amines undergo is reaction of amines with Grignard reagent. Grignard reagent is a very useful class of compounds. It can react with almost any class of organic compound, or we can say it can react with any functional group that belongs to organic compounds. And at the end, we shall see some specific reaction that is used to differentiate between primary, secondary, tertiary amines. And like previous practice, at the end of this lecture, there are some questions for your practice. We shall start with the first type of reactions of amines, that is salt formation. Amines being basic in nature, they have tendency to react with common organic or inorganic acids to form ammonium salts. We have three reactions at this slide, and you can see that in first two equations, the acid being reacting with amine is HCl, that belongs to mineral acid, or we can say inorganic acid. But in the last equation, here is acetic acid. Acetic acid belongs to organic acids. So these three reactions depict that amines have tendency to react with mineral acids as well as organic acids. So in amines, nitrogen can donate its lone pair to proton of acid, and after donating its lone pair, it forms coordinate covalent bond, and it is converted into ammonium cation. And to balance this cation, the negative part of acid form salt with ammonium. So the reaction of first reaction will be ethyl ammonium chloride, and you can see clearly that there is a space between ethyl ammonium and chloride. In our second last lecture, I told you the name of molecule consists of one word, and in contrast, the name of salt is comprised of two words. So you can see clearly that ethylamine is one word and ethyl ammonium chloride is two words name. Similarly, in the second equation, we have example of aromatic amine, that is aniline, reacts with HCl to form anilinium chloride. And in the third example, we have a secondary amine, that is tertiary amine, sorry, that is triethylamine reacts with acetic acid to form triethylammonium acetate. The second type of reaction is alkylation. As I told you in the uh, second slide that was about the contents of this lecture, alkylation. Primary amines react with alkyl halides to form secondary, tertiary, and quaternary amines. In this reaction, a hydrogen atom attached to nitrogen is replaced by an alkyl group and is therefore is called as alkylation of amines. So in this slide, we have a primary amine RNH2. It reacts with RX, and there is an elimination of hydrogen halide with the formation of a secondary amine, and this reaction can continue until the formation of quaternary amines. I remember that the first reaction that was used to prepare amines was alkylation of amines. So the same reaction can be classified as a reaction to prepare amines, and the same reaction is also considered as a reaction of amines. The amines used in this reaction may be aliphatic or aromatic. It can be either primary, secondary, or tertiary. Any sort of amine can react with alkyl halide to give a product next to it. Means primary will produce secondary, secondary will produce tertiary, and tertiary will produce quaternary amines. The reaction involves the nucleophilic attack of an amine on the electrophilic carbon of alkyl halide to form a substitute ammonium halide, which on treatment with a base gives a free amine. So this is exactly the same reaction that we studied in the preparative methods of alkenes, and in second last reaction I told you that two types of amines can be used at the second step. One of the amine is sodium hydroxide can be used, as well as ammonia can also be used as the second step. This is something like SN2 reactions. Uh, R of alkyl halide is electropositive halogen because halogen is more electronegative, so it will attract shared pair of electron towards itself, and there will be a partial negative charge on halogen and partial positive charge on alkyl group. So this R group is a nucleophilic center, so lone pair of nitrogen can easily attack on R group. So there is a formation of coordinate covalent bond between nitrogen and alkyl group. So this will become a ammonium cation. To balance this positive charge of cation, halide will encounter this cation, and there will be a formation of ammonium salt. So this ammonium salt is further broken up in the presence of base. So in some equations you will see sodium hydroxide, and in some cases you can see instead of sodium hydroxide ammonia is also used. In order to liberate amine from ammonium salt, the hydroxide ion should abstract a proton from the ammonium ion. The same work could be taken from ammonia. Since the quaternary ammonium ion has no proton to be extracted, however, alkylation of amines to the stage of quaternary ammonium can be used in two ways as described below. The first one is exhaustive methylation. When a solution of quaternary ammonium halide is treated with moist sulfur oxide, it is converted into quaternary ammonium hydroxide with the formation of precipitate of silver halide. We can see in the equation that tertiary alkyl ammonium halide is being reacted with silver oxide in the presence of moist medium. Halide of tetra-alkyl ammonium halide is replaced by hydroxyl group and with the formation of silver oxide. The aqueous solution of quaternary ammonium hydroxide obtained after filtering out the precipitate of silver halide is as strong alkali as sodium hydroxide. Evaporation of this solution to dryness gives quaternary ammonium hydroxide as a crystalline solid. An amine, whether primary, secondary, or tertiary, can be ultimately converted into quaternary ammonium hydroxide by treatment with excess methyl iodide and moist sulfur oxide. The process is called exhaustive methylation and may be used to distinguish between primary, secondary, and tertiary amines from the number of methyl groups used by the nitrogen of amine to be converted into quaternary ammonium salt. A primary amine will use three methyl groups, a secondary will use two, and a tertiary amine will use only one methyl. Second type is Hofmann degradation, a quaternary ammonium hydroxide on heating at high temperature above the boiling point of water undergoes decomposition. As the name depicts that degradation means decomposition. For example, when tetramethyl ammonium hydroxide is heated above 130 degrees Celsius, it gives trimethylamine and methanol by following SN2 mechanism. The reaction is known as Hofmann degradation because this is decomposition of a molecule uh, by the temperature, and we see within the molecule there are two centers. One of them is positive center and the other one is negative center. Heat provides uh, a source or a chance for the degradation of this compound with the formation of tetramethylamine and methanol. If the quaternary ammonium hydroxide contains an alkyl group bigger than methyl group, it predominantly undergoes elimination by E2 mechanism to give an alkene and a tertiary amine. The reason behind the elimination is that whenever there is a methyl group bigger than methane group, there will be presence of beta hydrogen in the molecule. As we know that the carbon next to methyl group is known as alpha carbon, and next to alpha carbon the carbon is known as beta carbon, and the hydrogen attached to alpha carbon are known as alpha hydrogens, and the hydrogen attached to beta carbon are known as beta hydrogens. If there is a methyl group, then there is only alpha carbon. There is no beta carbon, no beta hydrogen. But in case of any group bigger than methyl, there are beta carbons and beta hydrogens. And we know from nucleophilic substitution reactions and elimination reactions that in case of elimination, base abstracts hydrogen from beta hydrogen. So in the second equation, we can see that hydroxyl group is attacking on beta hydrogen, and it picks up hydrogen and it converts into water, and the remaining molecule ruptures with the formation of two molecules. One of them is tertiary amine and the other one is an alkene. If beta hydrogen is available at more than one position, the Hofmann product least substituted alkene predominates. Beta hydrogen, one butene will be produced in major and the two butene will be produced in lesser quantity. In your previous lectures, I expect you might have studied about Sitzeff's rule and Hofmann rule. Apparently, according to the stability of product, 2-butene is more stable, and the reason for the stability of 2-butene lies in the concept of hyperconjugation. The normal way the formal reactions support to the formation of 2-butene. But in these cases, the attack of hydroxyl group is difficult at the carbon that is situated in the center or in the middle of a molecule. The only option for the hydroxyl group in such type of molecules is to pick up hydrogen from the terminal hydrogens. That's why in such type of reactions, less substituted alkene is formed. But in normal reactions, highly substituted alkene is produced in major quantity and the reactions usually support to the production of high substituted alkenes. Third class of reaction is acylation. The replacement of a hydrogen of the amino group by an acyl group is known as acylation. Acylation of amine may be carried out with an acid chloride or an acid hydride and an ester. These three molecules, acid chloride, acid anhydride, and ester, these three molecules are derivatives of carboxylic acids. As I told you in previous lecture, that a derivative is a compound that always need a parent to be produced. Such type of molecules cannot be produced directly. And in previous lecture, I gave you the example of formation of carbon tetrachloride from CH4. Primary amines react with acid chloride or acid anhydride to form N-substituted amide. CH3NH2 with acyl chloride forms uh, the product with the elimination of HCl. Similarly, uh, aniline is being reacted with acyl chloride, and the mechanism of this reaction is similarly as the reaction of amine with the alkyl halides. Carbon has partial positive charge, so nitrogen can attack on this electrophilic center, uh, and when this bond is formed between methyl and NH2, the molecule rearranges with the formation of product. Secondary amines react with acid chloride to form NN disubstituted amides. You can see when acyl chloride reacts with dimethylamine, so with the nitrogen there are two alkyl groups. That's why the product is known as NN disubstituted amide. Tertiary amines do not react since they do not have a replaceable hydrogen atom at the nitrogen. As we know that in tertiary amines all the hydrogen atoms have been replaced by alkyl groups. Acylation is used frequently for protecting amino group. An example is the protection of amino group during the nitration of. As we know that amines are basic in reaction. Usually nitration is carried out by treating any compound with a mixture of sulfuric acid and nitric acid, because mixture of sulfuric acid and nitric acid produces NO2 group. Or nitration can also be carried out by treating any species with nitric acid. The difference between these two reagents is that when we use a combination of sulfuric acid and nitric acid, this is also known as fumic nitric acid, the rate of reaction will be higher. But if we use just nitric acid, the nitration could be carried out, but the rate of reaction is slow. So if we do nitration of aniline directly with nitric acid, then there will be a formation of anilinium salt rather than the formation of nitroaniline. So this means The reaction will occur with NH2 group rather than to be carried out on benzene ring. So it means initially first we need to protect NH2 group so that it does not take part in reaction, and reaction should occur at benzene ring. So for this purpose, initially NH2 group is converted into acid amide. Acid amide does not react with nitric acid. So you can see in the first step of this reaction, aniline is being reacted with acid chloride with the elimination of HCl to form uh, acetamide. Then this acetamide is being treated with nitric acid and we get a mixture of ortho and para nitroacetamide. These two molecules can further be treated with acidic or basic media, or we can say we can conduct their acidic or basic hydrolysis to rupture acetamide group to get back our amine. Actually, a protecting group is a group that is used to protect a group to avoid take part in the reaction, and this group can be recovered to the original group. The fourth type of reaction is carbylamine reaction. This one is also known as isonitriles. Aliphatic and aromatic primary amines react with chloroform in the presence of alcoholic potassium hydroxide to form isocyanide, isonitrile or carbylamine, which give a disagreeable odor and is therefore used as a test for primary amines. Secondary and tertiary amines do not give this reaction. Primary amine with chloroform plus potassium hydroxide gives us a reaction that is isonitrile. In the previous lectures, I told you three types of bond formation between carbon and nitrogen. First one was amine, when there is single bond between carbon and nitrogen. Second one was imine, when there is a double bond between carbon and nitrogen. And the third one was nitrile or cyanide, in which there was a triple bond between carbon and nitrogen. This is triple bond between carbon and nitrogen, but there is a difference between the position of carbon and nitrogen. If carbon is a part of chain and present inside the chain and nitrogen is at terminal position, then this class will be termed as nitriles or cyanides. But in contrast, if nitrogen is present inside the chain, inside the chain and carbon is present at terminal position and carries a negative charge, then this class is known as isonitrile. So sometimes a question as a short question can be asked to you: how do you know the difference between nitrile and isonitrile? Both type of amines can react, means aliphatic and aromatic. In the first equation you can see a primary amine, and in second reaction you can see aniline is being reacted with chloroform in the presence of alcoholic potassium hydroxide to produce isonitrile with the elimination of an disagreeable odor. Reaction with Grignard reagent. Grignard reagent is a multi-purpose reagent that reacts with water, with alkane, with aldehydes, with ketone, with ketone, with carbon dioxide, with propane, uh, cyclic oxide. I forget the name of cyclic oxide. So this is a multi-purpose class. So it can also react with amines. Primary and secondary amines contain active hydrogen. Therefore, they can react with Grignard reagent to give hydrocarbons. In this case, methyl group has a partial negative charge, and NH2 have CH3 have partial positive charge. So both of these two alkyl group from respective molecules will react with each other. Alkyl group that is attached to Grignard reagent is partial negative, and alkyl group attached to NH2 group is partial positive. So both of these alkyl groups carrying opposite charge react with each other with the elimination of an alkane. So this reaction is also studied in the preparation of alkanes. The second example represents the reaction of aromatic Grignard reagent with a secondary amines. This reaction abstracts hydrogen rather than methyl group from methylamine. So there is a formation of benzene molecule. The sixth reaction is reaction with aldehyde. Primary amines react with aldehydes and ketones to give condensation product, that is imine, called as Schiff base. Schiff base can be produced very easily, and this is a very useful class of organic compound. It has so many applications. Aniline can react with acetaldehyde in the presence of a weak base with the formation of Schiff base or water. So from here we also came to know that imines are also known as Schiff bases. Similarly, the second example contains aromatic aniline that is reacting with acetaldehyde to form an aromatic Schiff base with the elimination of water molecule. Now we come towards the last segment of this lecture, that is distinguish between primary, secondary and tertiary amines. There are following reactions that are used to distinguish between primary, secondary and tertiary amines. The first one is reaction with nitrous acid. Nitrous acid is unstable compound and is therefore generated in situ in the reaction mixture by reaction of sodium nitrite with dilute HCl. In my previous lecture, there was a reaction that in which hydrazine was being utilized, and I told you at that slide that hydrazine is available in the form of hydrazine chloride in the laboratory. So when we need to produce hydrazine, we use salt of hydrazine with some acid that produces in situ hydrazine. Similarly, nitrous acid is not available in the laboratory. So whenever we need to produce nitrous acid, we use a combination of sodium nitrite and HCl. So both of these molecules gradually react with each other and slowly produce nitrous acid, and this produced nitrous acid uh, in the course of reaction is utilized to react with other species. Aliphatic primary amines react with nitric acid to give alcohols with the evolution of nitrogen gas. Nitrogen gas is a brown color gas, so during this reaction, one can easily observe the liberation of nitrogen gas. Aromatic primary amines react with nitrous acid to form diazonium salt. This process is known as diazotization. This is a very famous reaction. This diazonium salt can further be used for the production of a large number of dyes by treating these diazonium salts with alpha naphthol, beta naphthol, and other aromatic phenols. And these dyes are very common that are used in textile industry. Secondary amines react with nitrous acid to form N-nitrosamine, which are water insoluble as yellow oils. So we can see dimethylamine react with nitrous acid and the reaction produces N-nitroso dimethylamine. Aliphatic tertiary amines react with nitrous acid to form salt, which are water soluble. Aromatic tertiary amines react with nitrous acid to form C-nitroso aromatic compounds. Nitrosation occurs almost exclusively at para position if it is open, and if it is not open, then it occurs at ortho position. So there is a reaction of N,N-dimethylamine with nitrous acid at 8 degrees Celsius, and the introduction of NO group is at para position. As it is mentioned in previous slide, that if the nitro position is occupied by some other group, then this NO group will either come at below ortho position, or it can come at upper ortho position, because both of these ortho positions are similar with respect to their reactivity. Second, sulfonation or Hinsberg reaction with benzene sulfonyl chloride. Primary and secondary amines react with sulfonyl chloride to form sulfonic acid amide, generally called sulfonamides. Primary amine react with RSOCl to produce RSO2 NH2 RCl. Then this molecule rearranges into an alkyl sulfonamide. Sulfonamide formation can be used to distinguish between primary, secondary, and tertiary amines in a test known as Hinsberg test. Primary and secondary amines react with benzene sulfonyl chloride to form substituted sulfonamides. Sulfonamides are usually crystalline solids. This test is performed by shaking an amine with benzene sulfonyl chloride in excess aqueous potassium hydroxide. Primary amines react with benzene sulfonyl chloride to form N-alkyl benzene sulfonamides, which are soluble in potassium hydroxide. Primary amine react with benzyl sulfonyl chloride with the elimination of HCl, produces N-alkyl sulfonamide, which is insoluble and reacts with potassium hydroxide to form a water-soluble salt. Secondary amines react with benzene sulfonyl chloride to form N and dialkyl benzene sulfonamides, which are insoluble in potassium hydroxide solution, and they will not give any further reaction. Tertiary amines do not react with benzene sulfonyl chloride. However, on acidification, the mixture, the tertiary amines will dissolve by forming a water-soluble salt. So the reaction shows that tertiary amine plus benzyl sulfonyl chloride, potassium hydroxide, there is no reaction. But if we add any acid in this reaction, then the tertiary amine donates its lone pair to proton to form ammonium chloride. So the question that I would like to ask at the end of this reaction, what is difference between nitrile and isonitrile? What is the chemistry of Hinsberg test? And the last one is, what do you know about Hofmann degradation? Thank you so much. I would like to say Assalamu alaikum. We'll see you in the next lecture. Allah Hafiz.